So let's see if we can evaluate the definite integral from 11 pi over 2 to 6 pi of 9 sine of x dx. So the first thing, let's see if we can take the antiderivative of 9 sine of x. And we could use some of our integration properties to simplify this a little bit. So this is going to be equal to, this is the same thing as 9 times the integral from 11 pi over 2 to 6 pi of sine of x dx. And what's the antiderivative of sine of x? Well, we know from our derivatives that the derivative with respect to x of cosine of x is equal to negative sine of x. Negative sine of x. So can we construct this in some way so this is a negative sine of x? Well, what if I multiplied on the inside, what if I multiplied it by negative 1? Well, I can't just multiply it only one place by negative 1. I need to multiply by negative 1 twice, so I'm not changing its value. So what if I said negative 9 times negative sine of x? Well, this is still going to be 9 sine of x. If you took negative 9 times negative sine of x, it is 9 sine of x. And I did it this way because now negative sine of x, it matches the derivative of cosine of x. So we could say that this is all going to be equal to, it's all going to be equal to, you have your negative 9 out front, negative 9 times, and I'll put it in brackets, negative 9 times the antiderivative of negative sine of x. Well, that is just going to be cosine of x, and we're going to evaluate it at its bounds. We're going to evaluate it at 6 pi. Let me do that in a color I haven't used yet. We're going to do that at 6 pi. And we're also going to do that at 11 pi over 2. 11 pi over 2. And so this is going to be equal to, negative 9 times, I'm going to create some space here. So, and actually, that's probably more space than I need. It's going to be cosine of 6 pi, cosine of 6 pi, cosine of 6 pi minus cosine of 11 pi over 2. Cosine of 11 pi over 2. Well, what is cosine of 6 pi going to be? Well, cosine of any multiple of 2 pi is going to be equal to 1. You could view 6 pi as we're going around the unit circle 3 times. So this is the same thing as cosine of 2 pi, or the same thing as cosine of 0. So that is going to be equal to 1. If that seems unfamiliar to you, I encourage you to review the unit circle definition of cosine. And what is cosine of 11 pi over 2? Let's see. Let's subtract some multiple of 2 pi here to put it in values that we can understand better. So this is, so let me write it here. Cosine of 11 pi over 2, that is the same thing as, let's see, if we were to subtract, this is the same thing as cosine of 11 pi over 2 minus, let's see, this is the same thing as 5 and 1/2 pi, right? Yeah, so this is, so we could view this as, we could subtract, let's subtract 4 pi, which is going to be, we could write that as 8 pi over 2. In fact, no, let's subtract 4 pi, which is 8 pi over 2. So once again, I'm just subtracting a multiple of 2 pi, which isn't going to change the value of cosine. And so this is going to be equal to cosine of 3 pi over 2. And if we imagine the unit circle, let me draw the unit circle here. So it's my y-axis, my x-axis, and then I have the unit circle. So, whoops, all right, the unit circle just like that. So if we start at, this is 0, then you go to pi over 2, then you go to pi, then you go to 3 pi over 2. So that's this point on the unit circle. So the cosine is the x-coordinate, so this is going to be 0. This is 0, so this is 0. And so we get 1 minus 0, so everything in the brackets evaluates out to 1. And so we are left with, so let me do that. So all of this is equal to 1. And so you have negative 9 times 1, which of course is just negative 9, is what this definite integral evaluates to.